Welcome to the Unified Project by Helena Zhao. In this video, we're going to explain two ideas that happen in this video. The first one is about the process that molecules go through when heat is added to a substance. Second, it will explain the graph that represents the change in the heat of the liquid. In this, you can see that the ice is being added to the water, and currently the temperature of the water is actually higher than the temperature of the ice, which causes bonds inside of the ice cubes to break apart and regroup, and then the temperature of the water will reach 6 degrees because of the increase in energy. And if you look at the graph, the slope actually stops increasing for a bit and come to a slope of 0%. During the time period of ice melting, this is because the change in the temperature and the change in the physical state of a substance cannot change at the same exact time. So another example would be chocolate chips in a microwave. The chocolate's temperature has to increase first for the form of chocolate to change from solid to a liquid form. As you can see, the temperature of the substance has reached to a steady pace of 6 degrees due to the energy increasing from the ice cubes. However, it has come to a stop because it was going through the process of changing from a solid product to a liquefied product. And on the bottom is a graph of what's going to happen in the future. As you can see, a set of heater was added into the water, which adds an extra amount of energy that caused the molecule inside waters to rub against each other actually faster, which caused the amount of water to expand and the amount of spaces between molecules to expand. This is basically what happened to a substance when the heat of the water is raised. It is the same idea when we're having ice cubes. It is smaller and more condensed because it has a lower temperature. However, when it turns into the water, it has a higher volume and higher existence because the molecules has expanded due to the increase in heat. As you can see, this is basically a summary of the graph of what happened in the change of temperatures in this entire process of water going from freezing to boiling, which is 100 degrees. That the steady pace where there's zero slopes usually means that they're going through a physical phase change, which means that solid are changing into liquid or liquid are changing into a solid. So in this video, in this part of the video that you can see the water has reached to a temperature of 100 degrees, which is actually the boiling point of the waters, which means that the water changes into water vapors, and as they evaporate into the air, it also takes away energy from the water, but at the same time the heater is also adding into energy, which creates a balance that maintains it at 100 degrees. So a question is that where does the energy from the water go, or is it destroyed or created? The thing is, if you look at the first law of thermodynamics, the first law says that energy can only be added or subtracted. It cannot be created or destroyed. So what does it mean is that these energy, they don't disappear into the air. They actually transfer from place to place. For example, the energy first go from the ice cube into the water. It wasn't destroyed or taken away. It would just change it to a different form and came into the substance. And then the water from the ice cube also changed into water vapor when it reached to a certain heat. And this certain heat, this amount of energy, helps take away more energy away from the water by going away as this gas form, which is the water vapor.